Hello and welcome back. Today we are diving into the concept of what is innate and learned behavior. This is one of my favorite topics. It's very, there is some science behind it, of course, but it also is a little bit like psychology based. So I always think the combination of like neuropsychology, stuff like that, is very interesting on a personal level, so I hope that you find this as interesting as I do. So let's define some of these words so that we know moving forward, when I say it, what it really means. So innate behaviors are an instinctive response. It's inherited from parents. It develops independently of environmental context. It just develops by natural selection. Species specific. This is not something that you need to learn. This is something that you just know how to do. So like spiders spinning a web, they are born knowing how to spin a web. Or a caterpillar making a cocoon, dolphins leaping from water, birds building nests. Like these are just things that as a species, they are just born understanding how to do. So kinesis versus taxis, these are more vocab words. So kinesis is a non-directional response to a stimulus. So for example, orthokinesis is the speed of movement that is altered as a response to a stimulus. So it's not saying that you are moving to the left or to the right. You're not having a positive response or a negative response. It's just, hey, this happened and now I'm going to move faster. Or I'm going to move slower. So non-directional. Whereas taxis is an innate directional response. So you can have a positive taxis where you're moving towards a stimulus, or negative taxis where you're moving away from a stimulus. So an example of this would be like paramecium have a positive thermotaxis. So when they sense that there's an area of water that's warmer, they want to be in it. They like bath water. And so they will positively move towards the stimulus, right? They will have a positive taxis. So this is a directional response. They're moving towards something or away from something. Again, kinesis is they're not moving specifically away from something or towards something. They're having some other type of response that is non-directional. And now, learned behavior, another like sort of vocab type word, is a behavior that is modified by experience. So this is not genetically programmed, but you do, well, it's like sort of, but not really genetically programmed. So offspring inherit the ability to acquire new patterns of behavior, right? Like I can learn new things. I am capable of that. My body has been programmed to accept new ideas and learn from them and continue growing. However, learned behavior, whatever behavior I am learning, is not something that I was innately born with. It's not something that I just knew how to do right off the gate. So this is the process of gaining new knowledge, skills, modifying existing knowledge or skills. It's dependent on the environment. So like putting myself or having you guys go into school every day is putting you into an environment to acquire new skills, right? You are learning consistently, whether you're making the connections that last, those neural development connections that actually last throughout your life, that is yet to be determined. But you are put into an environment that would, suggest that you are doing that. This may or may not increase your chance of survival. Like, of course, if you're learning how to cook, that would probably increase your chance of survival, right? You need to eat. But if you're learning how, I don't know, to like flip a coin, that's probably not super helpful in the long run. So it's really dependent on where you are and what you're learning. But in the animal kingdom, not counting humans, a lot of learned behavior does increase the chance of survival. That's why they learn it, because it's helpful. So let's talk about specifically this example of bird song. So when I'm sure you've heard birds singing in the morning, sometimes too early, but definitely you've heard birds having some sort of bird song. That all species have their own bird song. So the question is learning required or is it an innate skill? So this experiment was done with 3 different independent variables. There was an isolated bird that had never been exposed to an adult singing whatever their bird song is. The second IV is a bird hearing a recorded song, so they heard the song but it wasn't in person. And then the last one was seeing and hearing actual birds sing, like right in front of them. They were just trying to determine can the bird create a song and how good is the song? Well, the results are that the bird that was isolated did have a crude song. It wasn't very good, and it probably would not have attracted any mate. So they were kind of just singing an ugly song, basically. The group that was exposed to the recording had a closer to normal song. It wasn't perfect, but it wasn't bad. And then the group that was exposed to actual birds had the formation of a normal song. So the conclusion is that birds are born with a crude template. So there is some innate template of a song that birds are born with, but it's not good. It's not what other birds want to hear. Like, it's like, you know, when like you go to karaoke and like someone is singing and you're like, okay, why don't you sit down, buddy? It's like that, you know? But although it's there, they do need to learn from an adult, someone who does know how to actually sing the song, to be able to sing it like a normal adult and attract mates in a normal way. So bird song is actually both learned and innate, and there are a number of skills that are like that, where they have a basic understanding of what they're supposed to do, but they need to learn from an experienced member of their species to perfect whatever it is that they're doing. Okay, so let's go through a few types of learned behavior. So this example is called reflex conditioning, and maybe you've heard of Pavlov conditioning. Pavlov is a very, very famous psychologist. You can do Pavlov conditioning on anyone and anything. This is how a lot of people train their dogs, but you can, not that I'm suggesting you do this, but you absolutely can do this on like younger siblings too. So this is a method of associative learning. So in his experiment, he trained dogs to alter their response to a stimulus, and it was all based on the dog's expected outcome of the behavior. So this is reflex conditioning. You are creating a reflex to a stimulus, so an automatic response to a stimulus. In this case, what the actual experiment was that Pavlov noticed that his dog would salivate when food was present. Right? The dog was hungry. He would start salivating when he saw food. And there was no response when the dog heard a bell. Okay, it's neutral. They're like, I don't know, a bell just existed in the dog's world, but there was no association. So Pavlov started to ring the bell and give food at the same time, and you would see the dog start to salivate, right? This is called an unconditioned response, because we haven't actually done anything. We're just testing the waters here. So ringing the bell and giving food at the same time. Eventually, when the dog hears the bell, they have associated the bell with getting food. So even when there's no food present, when the dog heard the bell, it would start to salivate. So you can train anything and anyone to have an unconditioned response. and turn it into a conditioned response. It's a very interesting thing. It's just like your brain makes the connection that like A plus B equals what I want. And so you associate A and B together always when you've done enough of the conditioning. And eventually, yeah, you've trained them in a way that they were previously untrained in. It's interesting. It's kind of funny. Another type of learned behavior is imprinting. This is animals learning a response during a sensitive period. This is independent of the consequences of the behavior. So I want to make that very clear. This is independent of the consequences. So you can like have imprinting happen, and then the consequences are negative. In this case that we're going to look at right underneath this, Konrad Lorenz did this with geese. He wanted to investigate imprinting in geese. And what happens is when geese are born, they imprint on the first thing that they see and assume that that is their mother, which makes sense. But Konrad Lorenz took the mother away, and he was the first thing that the geese saw. And so they imprinted on him. And so, like, that is a consequence because now, like, he can't fly. He can't do all the things that geese need to do. So he was unable to actually teach the geese what they needed to know to, like, be successful geese. But he did prove that, like, imprinting exists. So innate releasing mechanism is when animals filter other stimuli and only respond to one that is significant. So in this case, this is they ignored everything around them and focused strictly on Lorenz because whatever he did, they would do. So like when he started to walk away, they would follow him, which is why you see like ducks follow their mom, or geese baby geese doing the same thing. When they're learning how to fly, they fly together. Okay, this is called a sign stimulus. So it's just what it's usually at the beginning of their lives when they're like still trying to figure out like who and what they are. And then our last type of learned behavior, I think, is operant conditioning. And so this is a form of learning that consists of trial and error. This was done and found by someone called B.F. Skinner. This is the Skinner box. And so in this particular case, this is the idea of positive and negative reinforcement. I'm sure that you've heard this in like other terms, like when people get in trouble, a lot of people will say that, you know, you need to do positive reinforcement. So like you're rewarding good behavior and not only like punishing incorrect behavior, because a lot of people have negative responses to punishment, and so they would rather get rewarded than be punished. I think that's in a general sense, everybody would rather get congratulated on doing something well than to get yelled at for doing something bad. So Skinner created this box, and basically what it does is there was a lever in the box, and rats were in the box. And so when the rat would press the lever, it would cause food to be released. And at first, it was accidentally pushed. Like, yeah, okay, I ran into the wall. I don't know, I'm a rat. I ran into the wall, I accidentally hit this, but oh my gosh, this piece of food came by. But eventually, the rat said, okay, every time I push this level, I get a piece of food. Well, that's a reward for the rat, right? The rat wants food. So positive reinforcement is continuing to push the level and getting food, right? So I'm doing something you want me to do. You want me to push this lever, and I'm getting food, so I'm being rewarded. A negative reinforcement would be like if they didn't press the level and they got like a little electroshock. Like that would be punishing incorrect behavior. And a lot of, as we have grown as a society, negative reinforcement has sort of been like a hot button topic of like, you don't want to do that in schools, you don't want to do that like parent to child, like it forms bad connections that you don't want to instill. So I have been talking about learning. What is learning, right? It's just the acquisition of a skill or knowledge. We've talked about this. Behavior changes are a natural part of growth and maturation. In a lot of cases, behavior changes are natural. However, in other cases, behavior modification, so actually changing your behavior, growing, all of that, like maturing, must occur by learning. So the degree of learning depends on the longevity of an animal and their neural capacity. As humans, we have a high neural capacity, right? Our neurons work very complexly with each other and with their targets. They also, like the folds in our brain are quite intense, so we have the capacity to learn quite a bit, and our longevity is high. We live for quite a long time, right? So the difference between us and like a mayfly that lives for 24 hours is we're probably going to learn more than a mayfly because we can live longer and we have the neural capacity to do so. So there are two types of learning, non-associative and associative. So associative learning is sort of what I had been talking about previously in this. So like classical conditioning, operant conditioning, imprinting, all of those examples like Pavlov, Skinner, Lorenz, all of that is associative learning. So an example of this would be like chimps learning how to forage or birds learning how to do their bird song through observation. Non-associative learning is like habituation and sensitization. So this is like getting used to repeated stimulus such as background noises. You're sort of like, you can increase a response to a repeated stimulus. It's all sort of like basic, like you're not associating anything with this, but you just sort of like get used to it. Whereas associative learning is like actively observing something or actively being taught something. And then memory. This is like sort of like the last bit that we're going to talk about is memory. So memory is defined as encoding, storing, and accessing information. So encoding is converting information into a form that can be stored by the brain. You don't just have memories, they are encoded into your brain. So you have to like actively convert information, and then you have short-term memory and long-term memory, and this is storing. So first you have to convert information, and then it gets stored in one of two ways. Short-term lasts about a minute. This is when like someone says, hey, can you remember this number for me? And you just have to spit it back out, a minute or two later. But long-term memory can be retained indefinitely. And this might be like your birthday. You probably want to remember that indefinitely. Or like your social security number. These are just pieces of information that you want to be able to retain forever because you just need them fairly consistently. So it goes from short term and it gets encoded into long term. And then accessing is the ability to recall information so that it can be used actively in thought processes. So the active form of saying, hey, I need my social security number, I'm going to quickly filter through my long-term memory and pull out that number, which is also why sometimes you have like a little bit of a lull before like you know something, but it just like takes like maybe like a half a second or even like a couple of seconds to pull it out of your brain. And that's just because your brain is so full of information. It takes a little bit to recall that information. And that is everything for this. I hope that you found it as interesting as I find this. We are going to do a few different reflex activities to test your own ability to go through all of these different types of learned and innate behaviors. So I will see you in class. Good job.